Hello everyone! Some time ago I come across a very interesting problem. My son and I decided to divide a square sheet of paper into 100 parts into 100 equal squares. We started by dividing it into 10 equal width strips. It wasn't as easy as it first seemed. We can divide the sheet in half, into 4, into 8 parts, but dividing it into 5 or 10 parts is a trickier task. Now we are going to solve it and prove it from the perspective of geometry. The main solution involves folding the sheet of paper in such a way that the fold line extends from the bottom left corner to the middle of the right side of the square. The angle will indicate the necessary point. I'll demonstrate. It's quite hard to explain. We fold the sheet so that this right bottom corner ends up here at the intersection point of these two circles. A larger circle whose radius equals the side length of the square, and a small circle whose radius is half of side length of the square. Here are the radii. Here they intersect, and we fold the sheet to here. Here the fold line, and we bring this corner here, and we get triangle here. Actually, the solution to this problem is this point that divides the side of square in a ratio of 1 to 4. Horizontally, it divides the side in a ratio of 2 to 3. This means that to solve this problem, we need to first consider this small circle, and specifically this segment. I prepared everything in advance to save the time. Yes, and then the larger circle. So, we make such constructions. We have a circle segment that is formed by these two radii. Our task is reduced to find this height or this height, which is the same. To find it, we'll of course use the Pythagorean theorem. I will indicate what and where is located. This chord will participate in the calculations. Rather, it's half. Let's call it small l. This is radius. This is also radius. And this is radius too. And it consists of h, which we need to find. And accordingly, radius minus h. We are going to apply Pythagorean theorem to this triangle a bit later, but let's first make all the notations for the larger circle. Here everything's the same. Here is the chord, let's call it L large. Here is the height. Here 3 radii, and accordingly the radius is here. This is a large radius, as we understand, it's equal to the length of the square side. Let's call it A. Well, now let's move on to the Pythagorean theorem. It says that the sum of the squares of the legs is equal to the square of the hypotenuse, if anyone doesn't remember. The first leg is L squared. The second leg is R minus H squared. Their sum equals the square of the hypotenuse. The hypotenuse is a small radius. The small radius, as you understand, is equal to half the large radius. This is clear from the condition. So, we can get H from here, but as you can see, we don't know L. And that's a problem. Otherwise, the task would have already been solved. That's precisely why we also consider the large circle. Yeah. Here it is all the same. Large L and large R minus H squared. We can also get H, but as on the right side, here is the large L, which won't allow us to carry out the calculations. It's also important to note that large L plus small l equals the side of the square here. This is our missing link. Next, we rewrite the mathematical expression to find the large L square. It turns out to be 2RH minus H squared. The same thing we do for small l. From this formula, we deduce that it equals RH minus H squared. Next, we return to our condition that large L plus small l equals R. We put all this into one equation and then we conduct mathematical transformations. All this is quite simple. We square several times to get rid of the roots. Here I even skipped some steps. I think if you want, you can do all this yourself without difficulty. Finally, we eventually get a standard quadratic equation. 5h squared minus 6rh plus r squared. We are looking for h. R is known to us. It's equal to the side of the square. Remember, if anyone has forgotten, we are trying to prove that this h equals 1/5 of side of the square. I remember that I initially talked about 10 parts, but to divide the square into 10 parts, you just need to divide each fifth part in half then. So, transformations, quadratic equation, the discriminant is equal to b squared minus 4ac. Here everything is reduced. Obviously one of the roots equals r, but of course we don't take this into account. I believe there should have been a domain of permissible values somewhere that would have immediately dismissed this option, but now we have actually proven that h equals r divided by 5, that is the side of the square divided by 5. That's it. I think it's genius, simple, beautiful, and very useful. What do you think? You might also be interested in watching my old videos about how to draw a perfect star without compass. The link will be in the description. Thank you for watching, for your attention, and see you again.